Hello everyone, welcome back to my channel. In today's video, we will be discussing about rational functions. This lesson is part in your general mathematics subject or even in junior high school mathematics subject. So we have here the outline. We will gonna review polynomial functions, then real-life situations that can be modeled by rational functions, and definition of polynomial function. Then let's define a polynomial function. So a polynomial function p of degree n is a function that can be written of the form, okay, you have here p of x is equal to a sub n x to the power of n plus a sub n minus 1 times x to the power of n minus 1 plus a sub n minus 2 times x to the power of n minus 2 plus and so on and so forth plus a sub 1x plus a sub 0, where a sub 0, a sub 1 to a sub n are elements of real numbers, where a sub n must not be equal to 0 and n is a positive integer. Each summand is a term of the polynomial function. By the way, summand here is actually a term of summation. It is synonymous with addend. The constant, okay, for a moment. The constant a sub 0, a sub 1, a sub 2, and so on until a sub n are the coefficients. And the leading coefficient is a sub n. Now the leading term is a sub n x to the power of n, and the constant term is a sub 0. Okay, let's have a definition of a rational expression. A rational expression is an expression that can be written as a ration of two polynomials. Now this can be described as a function where either the numerator, denominator, or both have a variable on it. Okay, identify whether the following algebraic expressions, if they are rational or not. So for instance, you have x squared minus 4x plus 5 all over x minus 1. Okay, is that algebraic expression rational or not? What do you think? Okay, you have here, it is a rational expression because it is a ratio of two polynomials. Okay, both the numerator and denominator are polynomials. Let's proceed to the second example. How about that one? You have 1 over 5x squared. Is that a rational expression or not? Okay, and you're right. It is a rational expression because the numerator is a polynomial of a degree 0. You might be wondering, our numerator there is 1. Okay, that is constant. And for every constant, always remember that is still a polynomial of degree 0. Because any variable, remember, any variable raised to the power of 0 is always equal to 1. Okay? So our constants are always considered as polynomial when expressed that in a ratio form and there's a variable in either numerator and denominator. Okay, let's proceed to another example. How about 2x squared plus x minus 4 all over 3? Is that a rational expression or not? Okay. it is still a rational expression because, again, 3, the numerator 2x squared plus x minus 4 is a polynomial, and 3 is also considered as polynomial of degree 0. Okay. How about the fourth example? You have square root of x plus 1 over x squared minus 4. What do you think? Is that a rational expression or not? Let's check. What have you noticed with in the numerator? Okay, so this is not a rational expression since the numerator is not a polynomial. Because you have there, the numerator is square root of x plus 1. Okay? And square root of x plus 1, the exponent there is 1/2. So, it's not, therefore, it's not a rational expression. Okay. Rational expression, how about 1 over x plus 3 all over x minus 2? That is also a rational expression, even though in that particular example, you have 1 over x plus 3 all over x minus 2. The numerator is also in fraction form. It's already a rational expression form. But we will go back to the definition of rational expression, that is a ration of two polynomials. So if you're going to express that, we can have, remember the ratio and proportion discussion we had before in our previous videos. We have there that can be simplified as 1 over x plus 3 times x minus 2 is equal to 1 over x squared plus x minus 6. That is actually dividing both sides of the equation by its least common multiple. So that is a rational expression. Okay, now let's have an example and definition of a rational. Let's have a rational equation. So an equation involving rational expressions. Okay, if we have an example of a rational expression, we also have the so-called rational equation. If it is an equation involving rational expressions, then we call it the rational equation from the root word equal or equate. So we have here an example. We have 3 over x minus 1 over 2x is equal to 3/4. How about rational inequality? What is the definition? So, rational inequality is an inequality involving rational expressions. Example, you have 5 over x minus 3 is less than or equal to 2 over x. So what are other examples of inequality symbols? You have less than or equal to, greater than or equal to, or not equal to. Okay, let's proceed. How about rational function? A function of the form p of x over q of x, where p of x and q of x are polynomials, and q of x is not equal to 0. Meaning, what will happen if q of x, which is actually located in the denominator, if it will be equal to 0? What do you think will happen? So the expression will be undefined. Okay, let's proceed. Let's have an example. Okay, so you have f of x is equal to x squared minus 4x plus 3 all over x minus 1. That is an example of a rational function. Or you can have y is equal to x squared minus 4x plus 3 all over x minus 1. Remember, f of x or function of x is the same as y. Okay, let's proceed. Okay, procedure in solving rational equations. So we have the first step. You have eliminate denominators by multiplying each term of the equation with the least common denominators, or the LCD. Okay. Then note that eliminating the denominators may introduce extraneous solutions, and check solutions of the transformed equation with the original equation. Extraneous solutions, this refers to solutions in which if you are going to substitute the value of that particular variable in the original equation, it would actually make the equation either undefined or it won't equate the equation. So that is not a part or not a solution. We call it extraneous solution. Okay, let's have example number 1. Okay, suppose we're going to solve for x. We have here a rational equation. 2 over x minus 3 over 2x is equal to 1 over 5. Then we have the solution. Okay, you have 2 over x minus 3 over 2x is equal to 1 over 5. We are going to look for the LCD, the least common denominator. Okay, the least common denominator, I think you know already how to solve for the least common denominator, how to get the least common denominator when you were still in the elementary and in junior high. So I will not going to repeat that one. So you have here the least common denominator with the denominators x, 2x, and 5 would be 10x. So you are going to multiply both sides of the equation by 10x. So we will have, that is 10x times 2, that will give you 20x. Then 20x divided by 2, 20x divided by x, that will give you 20. Okay, x will be cancelled out on the first fraction. Next, because we are distributing 10x now to every numerator in that expression. So 10x times negative 3, that is negative 30x. Then negative 30x divided by 2x, that is negative 15. Are you able to follow? Next, 10x times 1, the next numerator on the other side of the equation is 1. You have 10x times 1, that's 10x. Then divided by 5, that is 2x. So we now have 20 minus 15 is equal to 2x. The next thing we're going to do is we are going to subtract. We have 20 minus 15, that is 5. Then just copy equals 2x. Okay. Then we have 2x is equal to 5. Rewriting the equation and replace the expression with the variable x on the left side of the equation. You have 2x is equal to 5. Then divide both sides by 2 in order to eliminate 2. So you have 2x divided by 2, that is x. Then you have x is equal to 5 divided by 2. Okay, so our value of our x is 5 halves, or 5 over 2. Okay, I hope that number one example, or the first example, is clear. Now let's proceed to another example. Now solve for x. We are still dealing with rational equation. You have x over x plus 2 minus 1 over x minus 2 is equal to 8 over x squared minus 4. Okay. The first thing that you're going to do, always remember that the basic foundation of this lesson is um, your knowledge on how to get or identify the least common denominators. Okay. So in this case, the denominators are x plus 2, you also have x minus 2, and you have x squared minus 4. So what have you noticed with the denominators? What do you think is the least common denominator? So we have here, you have here the difference of two squares, x squared minus 4. That is actually, let's go back. So we have here x over x plus 2 minus x minus, again, I'll repeat. Now let's proceed to example number 2. You have solved for x. You have x over x plus 2 minus x, again. Now let's proceed to example number 2. We have here solved for x. In our rational equation, we have x over x plus 2 minus 1 over x minus 2 equals 8 over x squared minus 4. Now always remember that it's just easy for us to solve for the value of x, to solve for a rational equation with the basic foundation that you should know how to get or identify the LCD. Okay? Since you have learned already, you have practiced identifying LCD when you were still in the junior high, now we're just going to apply your previous knowledge in it. So you have x plus 2, x minus 2, x squared minus 4 are our denominators. Now what have you noticed with our denominators? What do you think would be the LCD, or the least common denominator? Okay, so we have, writing it first. Okay, remember that x squared minus 4 is the difference of two squares. And that can be factored as x plus 2 and x minus 2. Okay, it's easy for us to get the LCD, so we can try to compare the rest of the denominators. So it will actually facilitate us on what would be our LCD. So our expression now is x over x plus 2 minus 1 over x minus 2 is equal to 8 all over x plus 2 and x minus 2. With our LCD, we're going to multiply both sides of the equation. Our LCD will be x plus 2 and x minus 2, meaning that is the least common denominator that can divide our denominators. So we are going to distribute our LCD to our numerators. We're going to multiply it to each expression. So you have x plus 2 x times x minus 2 times x, then divided by x plus 2. We can just mentally solve it, since the denominator of the first expression, x over x plus 2, the denominator is x plus 2. So if we are going to multiply the LCD to x, then divide it by x plus 2, then automatically we can cancel out x plus 2. So what remains would be x minus 2 times x. Okay? Then copy the minus sign. Let's proceed to the second expression. The LCD which is x plus 2 times x minus 2. We're going to multiply that to the numerator, which is 1. That will result to our LCD. Then divided by x minus 2. So basically, we can cancel out x minus 2. So what remains now is x plus 2 times 1. Let's proceed. Is equal to, you have the LCD times 8. That will give us 8 times the LCD itself divided by the denominator, which is x plus 2 and x minus 2, which is the same, exactly the same as our LCD. So we're just going to cancel out. Then what remains is 8. Let's proceed. Continue. So we have here, we're going to distribute x to each of the term and the binomial. You have x times x, you have x squared. Then x times negative 2, you have negative 2x. Then you have minus, copy the minus sign. You have x times 1, you have x. Then 2 times 1, you have 2. Then is equal to 8. Okay, let's continue. Now you have x squared minus 2x minus x plus 2 is equal to 8. Combining like terms, you have here x squared minus 2x minus x minus 2. We distribute the minus sign of the binomial. So we have minus x and minus 2. Then copy equals 8. Then combining like terms, you have x squared minus 2x minus x minus 2 minus 8 equals 0. We transpose 8 to the other side of the equation. Okay. Then we have x squared, negative 2x minus x, that is negative 3x. Then negative 2 minus 8, that's negative 10, then equals 0. Then x squared minus 3x minus 10 equals 0 is actually a perfect square trinomial. So we can actually factor this out. So x squared minus 3x minus 10 equals 0. Always remember that your knowledge in factoring trinomial is also needed. Your skills in factoring trinomials is very important for you, so you can answer, you can solve rational expressions. So you have here the factors of x squared minus 3x minus 10 would be x minus 5 and x plus 2. Okay. Because the products of negative 5 and 2, you have negative 10. And the difference between negative 5x and 10x is negative 3x. So we have now two solutions. We have x minus 5 is equal to 0. Then, or x and x plus 2 equals 0. Then we're going to solve for x. Your x sub 1 is 5. And your x sub 2 is negative 2. Now we are going to try solving, substituting the values of our x to the original expression. Okay, now check for extraneous solutions by substituting the answers back into the original equation. So we would know if it is really the solution or not, or if it is an extraneous solution or not. Okay, our original expression or equation is x over x plus 2 minus 1 over x minus 2 is equal to 8 over x squared minus 4. So substitute x equals 5 to the original equation above, since our first value of our x that we have solved is x equals 5. So we're going to substitute that value. So will it give equal answers to both sides? So that is for us to find out after we after substituting 5 in our variable x. So again, substitute x is equal to negative 2 to the original equation above. Same procedure for our second value of x. And what is the answer? Okay, since x equals negative 2, okay, by the way, you will just going to solve it on your seat or on your own. Substitute x equals 5 to the original equation. And you've noticed there that the answer, both equations are equal. And when you substituted x is equal to negative 2, you have observed that it makes the original equation undefined. So if it makes the original equation undefined, then it is an extraneous solution. Then x equals 5. Since it only satisfies the original equation, that is only our solution or the value of our x. Okay. Let us proceed to the third example. Now this time, we will use a word problem. It is a sort of application in the real life situation on how this rational equation used in the real life scenario. Okay, let's have a word problem. So in an inter-barangay basketball league, the team from Barangay Palinpinon has won 12 out of 25 games, a winning percentage of 48%. Now, how many games should they win in a row to improve their win percentage to 60%? So we're gonna apply the concept of rational expression in order for us to solve this question or word problem. So we have here the solution. Let x represent the number of games that they need to win to raise their percentage to 60%. And then the team has already won 12 out of their 25 games. So if they win X games in a row to increase their percentage to 60%, then they would have played 12 plus X games out of 25 plus X games. So that would be our expression. Thus, the equation or the rational equation is given by, you have 12 plus X over 25 plus x is equal to, what do you think? That is 0.60. Because I would like to know the number of games in a row that we're gonna win to increase their percentage to 60%. So this is now our rational equation. You have 12 plus x over 25 plus x is equal to 0.6. You have 12 plus x is equal to 0.6. You cross multiply. You have 0.6 times 25 plus x. Then you have 12 plus x is equal to, we will distribute 0.6 to 25, you have 0.6 times 25, that's 15. 0.6 times x, that's 0.6x. Then, combining like terms, you have x minus 0.6x. We transpose 0.6x to the other side of the equation. That becomes negative 0.6x is equal to, you just copy 15. Then transpose 12 to the other side of the equation. That becomes minus 12. Then you have 0.4x is equal to 3. Okay? To eliminate 0.4, we will divide both sides by 0.4. You have x is equal to, that's 3 divided by 0.4 is 7.5. Okay, that's our value of x. Since x represents the number of games, now this number should be an integer. Okay, so we are going to round it up. We're going to round up this one. Therefore, Barangay Palinpinon needs to win 8 games in a row to raise their winning percentage to 60%. Okay, now let's have a sheet work. Find the solutions for each rational equation below and make sure to check for extraneous solutions. You try to do it on your own. Okay, so you have here number 1 to 4. You have 3, number 1, 3 over x plus 1 is equal to 2 over x minus 3. Number 2, you have 2x over x plus 1 plus 5 over 2x equals 2. Number 3, you have x squared minus 10 over x minus 1 is equal to negative 14 minus 5x all over x minus 1. And number 4, you have x squared minus 4x over x minus 2 is equal to negative 14 minus 9x over x minus 2. So you have to try answering this on your own. And after answering, I want you to check. We have here the answer key on this 4-item sheet work activity. So we have here, after answering, you try to check with the answer key because this is just a sort of practice. Okay, here are the answers. But I would suggest that you'll do first, try solving it first before looking at the answers. Okay, so you will just simply check as to you are able to follow the steps on how to solve rational equations. So the answer for number 1 is 11. That's the value of x. For number 2 is negative 5. For number 3 is negative 4 and negative 1. So you have two solutions. You have two values of x. And then for number 4, you have negative 7. Okay? So I hope that your answers are all correct. If not, then just keep on trying and keep practicing. Okay? Then at this point, I'll be giving you another comprehension check. Since you're done practicing on your own, now this time you will be solving. Okay. Solve each equation and remember to check for extraneous solution. There are 8 rational equations for you to solve. I'm gonna read each rational equation. So you have here number 1. 1 over 6k squared is equal to 1 over 3k squared minus 1 over k. Number 2. 1 over n squared plus 1 over n is equal to 1 over 2n squared. Number 3. 1 over 6b squared plus 1 over 6b is equal to 1 over b squared. Number 4. b plus 6 over 4b squared plus 3 over 2b squared is equal to b plus 4 over 2b squared. Number 5. 1 over x is equal to 6 over 5x plus 1. Number 6. 1 over 6x squared is equal to 1 over 2x plus 7 over 6x squared. Number 7. You have 1 over v plus 3y plus 12 all over v squared minus 5y. I'm sorry, that is again number 7. 1 over v plus 3v plus 12 all over v squared minus 5v is equal to 7v minus 56 all over v squared minus 5v. And number 8, the last number, you have 1 over m squared minus m plus 1 over m is equal to 5 over m squared minus m. Okay, so I hope that everything is clear, and just to remind you that all you have to do then is please do master on how to get the LCD and then the factoring as well. So it will be easier for you to solve rational equations. Okay? So I hope that you enjoyed our discussion in today's video. And before I'm going to end this video, let's have a quote. So we have here a quote from Denise Gaskins. We have here, learning math. Okay, for a moment. Learning math is more like taking a meandering nature walk than like climbing a ladder of one topic after another. Students need to wander around the concepts, notice things, wonder about them, and enjoy the journey. Okay, so that's all for today's video lesson. I hope that you learned something. That would be all. And don't forget to subscribe my channel. Bye.